Welcome, everyone. I'm Ryan Anderson, as it shows up there. My job title is Senior DevOps Engineer. In years past, I was a System Administrator, focusing on Linux. In the last 4 years in particular, my main focus of work is on a daily basis is with Kubernetes and with Rancher Kubernetes. So my organization is NMDP, and when we were founded in 1986, we were the National Marrow Donor Program. We're a bone marrow registry. So the mission of what we do is we help people survive various blood cancers. Leukemia is the most common, but there's a few others. But in many cases, cancer can be a death sentence. This is one where quite a lot of people are able to be cured because if you have it, the first thing that your doctor will do is try to see if a family member can donate to you. When that doesn't work out, then they will interface with our systems and with our organization, and we have millions of people who are willing to donate. We have I'll just say an algorithm that's able to match through decades of experience who is a good match for you. And there's a whole team that will contact these donors, see if they're still willing. But that's kind of the main thing. But we do a lot of things with clinical trials, with research. Quite a bit of our compute power is taken with that research, post-clinical research to improve our algorithms and matching.
So I think I'll follow up on what you're saying before I go to the other guys. When we chatted before, one thing that really surprised me was how much of your organization was essentially an IT play. You know, because you think of a charity and you think there's maybe sort of one IT guy and there's a few sort of fundraisers and stuff, but actually IT is a small bit. But what you're saying is actually the technology is a fundamental platform for the charity.
That's correct. So our organization is about 1,200 employees. Our IT organization, I should have get the official numbers, but it's certainly about 20% of our organization. Wow. And that's really in large part because if, for example, you're a manufacturing organization or a finance, you can go and get third-party software that kind of you can build off of. We're a bone marrow registry, and there's really only a handful in the world, and so our needs are very unique, and we're, in a way, are kind of our own SaaS provider, you could say. But
yeah. So what's the special sauce? What you actually, because there's obviously complexity of data, because you'll know more than me, there's huge amounts of data points. You want to maximize your reach across the world, I would have thought, for the rare disease. There's also speed of response, I imagine, is also extremely important. Patients don't have a very long time to find something. So how does that complexity and that speed play into what solutions you need?
Yeah, that's a great question. So the systems that we run need to be high performance. So there's a whole process of applications that are used by transplant centers, doctors, and researchers. But when a sample is taken from a patient, that's received in our lab. The data is taken for that, and a search is made to look for that match. And we have metrics around that. It's very important for us that is very quick, and the process. When a match is found, think of it like a trapeze. When there's two people swinging, they have to meet at the top at the same time. Once that donor is found, once their donation is given, there's really about 3 days that it must be received by the person needing it.
And what is the SUSE technology and what you've implemented recently? What has that allowed you to do differently than before?
Yeah, so we started our Kubernetes journey in 2020, and we went from an environment that our developers were really pretty advanced for their time. So I started with our organization in 2016, and they were already just about 100% of custom applications on Docker. What happened, though, is they were so good at it that we had several hundred VMs. Maybe some of you can relate. Hundreds of VMs running Docker CE. And we tried to implement a Docker swarm-based solution in 2017 to to lessen this sprawl and make a standard way to deploy applications, it didn't work for us, obviously, because 3 years later we went to Kubernetes and we evaluated a couple, and Rancher won handily. In fact, we against our requirements.
What was it that made it win?
We needed it to work for supporting AWS and on-premise. We had several different ways of deploying Docker apps in AWS. We had several different ways of deploying Docker apps on-premise. We wanted one way to manage it. We needed role-based access using Active Directory. Seems basic, but not all solutions did that. One of them we tried, their solution was, well, just run one cluster for every team or every app, which seemed a little interesting. But Rancher, the value it provides in that respect is we needed to restrict access, and Rancher was able to, using its projects, if you're familiar, you can associate Active Directory groups to that, and in turn restrict it to different namespaces under it, and that was a big deal for us. And
Thomas, thank you very much,
and more.
Ryan. Thomas, you give the microphone to Thomas. Thomas, tell us about you and your organization and what you do.
Hi. Well, my name is Dr. Thomas Kronsitter. I'm from MTU Aero Engines, located in Munich, about Munich, say. Our company, in general, is kind of a junior partner in the big aircraft engine programs. So we are working in development of aircraft engines, turbo engines. We are building engines, and we are maintaining engines. So actually in almost every third plane or around the world there are parts that went through the hands of a MTU employee in any kind.
So how do you use, I mean, it's for somebody, an aircraft engine, how does technology feed into that, and how does your work feed into optimizing the parts that you're building for the engines?
Well, actually, these aircraft engines are at the very edge of the physically and technology, from the technological point of view possible.
Well, because you're trying to always get more and more fuel efficiency.
On the edge, what can be done? So you need very high knowledge in engineering, and of course you need enormous amounts of computational power. So we have a huge HPC cluster of our own, which had its origins in the late 1990s. So we started with a small Beowulf cluster, and now we have some 2,000 nodes running on-site at Munich. So we're kind of top 500 cluster. If we take all computational power in one.
So what are you doing? Are you basically running millions and millions of simulations that sort of concurrently just try and find the best aerodynamic flow, or what are you doing?
This is one of the major parts, but you also have to guarantee structural integrity of the parts, because what you really don't want is that the engine disintegrates when you are during starting phase or when you are airborne.
It's not ideal.
It's a very bad feeling, no?
Yeah. So what's the stack you're running at the moment? Where have you got to now? What are you doing with SUSE and SUSE's companies?
We're doing almost everything with SUSE. we're running most our engines with the computers, the servers based on SUSE/. And recently we've added the Rancher Kubernetes suites. So for the more enterprise part of our business, the Kubernetes gives us additional flexibility in our usage. We also have SLES for sub-applications and something like this. We have huge sub-servers. Actually, in my area, we serve little workstation servers, remote workstations. And the biggest machines are some 8-core machines with terabytes of RAM.
So you're in the tech for good category. I guess you're looking to always drive fuel efficiency. I guess that's the big the big demand for the aircraft industry and the airline industry is to be ever more efficient for economic reasons, but also for environmental reasons.
In terms of the product, we are in the lucky position that any improvement in the product produces CO2 emissions. So lately there has been the geared turbofan, which has been introduced some 2 or 3 years ago, and we've already saved about 10 million tons of carbon dioxide with the product. Additionally, on the IT side, we always try and work as sustainable as possible. For example, we have established such recycling or reusage chains. So a server starts as maybe enterprise machine, then it gets an HPC server, and finally in its sundown phase you get a remote workstation server on it. And everything is based actually almost on the same SLAS, because we have a strongly image-based installation procedure. Imaging means really copy each bit of a builder machine and deploy it on any number of servers that you like.
So what's the ultimate goal? A carbon neutral engine? A sort of a fully fuel efficient engine?
This is our goal for the next years till 2050. Well, there are several ways to get to that, because the innovation cycles in aircraft operations is very large. So a typical product life cycle is about 40 years. So
40 years.
40 years, and it takes some 10 years of development until you can put an engine you've started with an idea with into service, and then it'll run about for 30 years.
So the engines you're ideating at the moment will be in planes until 2070?
Yeah. Currently, you always have to continuously try and think what can be improved. So the last improvement was the geared turbofan. Then there is, in classical engines, you have maybe the water enhanced turbine. It's a technical term, just notify it. But additionally, you also try and use sustainable air fuels. That's not simply just taking another Zapfsäule,
fuel element, yeah, fuel type, yeah.
And you have to certify, you have to run tests, and it's really a huge amount of work behind that.
You have to have a crystal ball to do your job.
Finally, there is a stream to get into electricity. Means a flying fuel cell, and you have an electric engine.
And computing power is the only way you can do that, essentially.
Fuel cells, yes.
Marcus, thank you very much. You're from the University of Luxembourg.
Yes.
So when I was a student, I did all my exams at a desk, holding a pen, on a piece of paper.
This time is over, at least in Luxembourg.
Ich bin ein Dinosaur, clearly. So tell me about the journey that you've been on, and I guess particularly COVID, and how that affected what you've been doing.
Yeah, my name is Markus Scherer. I'm working at the University of Luxembourg as an infrastructure engineer. And I'm working in the LUCET. The LUCET means Luxembourg Center for Educational Testing. And as the name said, we do educational testing. We do once a year a huge test with around 12,000 students, and over the year, let's say in total we test 30,000 students, and we do that nationwide.
30,000?
Yeah.
So I guess...
Not at the same time, but over the year.
So when did that process start to go online and with using technology?
There was an early start in 2006, but it was just first steps to check could it work online. And I remember we always had the paper version as a backup.
Yeah.
Because
so
we are not sure.
Maybe you had to run in with a paper copy in the very first one.
Yes, kind of.
So fast forward to now. So you're doing every exam. Is that right? Is remote or almost?
It's you can compare these tests like the PISA tests.
Yeah.
But there's specialized to Luxembourg in language and in math. And it's to measure the performance of the students over their whole school life.
Got you.
And it's, at the end, it's to improve the educational system.
So,
Yeah.
so essentially, you have a whole cohort of kids that are being tested throughout their whole school life, online via the technology that you implement and the systems you implement.
Yes, yes.
So how do you do that? What is the infrastructure that backs this up? What have you had to do, and how have you had to evolve that over the years?
First, we have our software that is in-house developed. It's a special testing software where we can put our items in. That also all the items are get created at university. This software running on a SUSE cluster in VMs. And to control the whole infrastructure, we use the SUSE Manager. It is a big help. So without SUSE Manager, no way to do that. And
why is it so complex? What makes it so complex? Is it you have to check people are who they say they are? You have to make sure they're not cheating. Is there quite a lot of what's the complexity?
Yeah, it's not possible actually to cheat because we send several sets of tests out in the schools, and they get a login from us. Every individual student get his login, and with this login, he see his test set, and the sets are so that there are never two sets, the same sets in the same row.
You're one step ahead of the game.
So even if they
How annoying.
look at the other screen, they can't do nothing with that.
Very good. So you were talking about how the sort of IT needs of computing needs have changed over time. What's the most recent thing you've had to do? So you've moved to containers, you moved to Kubernetes.
We're thinking about containers in the future, but for now everything is running fine. There is no reason to change, but container will be the future. I guess when we have to modernize the infrastructure, that will be the way to go.
Well, we've just bought a good observability platform, Marcus. So, so maybe there's something in the future there. So, what do you see the impact that this has done? Because we're talking about sustainability and positive societal impact. Has sort of a technological solution allowed you to do something that simply wouldn't have been possible?
Yes.
Another way. Tell me a bit about that.
Before we use the online tests and we give the feedback to every individual student, we have to print out it and to send it in the schools. So it's not just that you send a box with all the results, you have to pack every individual result in an envelope, put it in a box and send it to the school. School by school, class by class. So that was also a big effort for the logistics. We need a lot of space to stock the paper. It was more than 1 million sheets of paper per year, A4.
1 billion?
Million.
1 million.
Million.
1 million sheets of paper. In a small place like Luxembourg,
Yeah.
that's a lot. Yeah.
So we saved all that to the online tool.
And is it more meritocratic in some ways as well? Everyone gets the same online tool. More
Yes.
democratic in some ways.
It's the same for everyone.
Yeah, I can see that. What's next? So Ryan, what's the next sort of thing you want to do? I mean, you sound like you've got 20% of your workforce working in IT, which is incredible. You already have earmarked, I would have thought, every efficiency that you could. When your CEO asks you, so Ryan, what's the latest IT thing that you're going to do that's going to really affect our patients? What do you say to them?
Oh boy, for us, we're always looking to be more efficient. Some of the subjects of this very thing where we're meeting here is like sustainability. We went from approximately 400 Docker CE VMs to about 150 Kubernetes nodes. So we've already seen a lot of savings with. We're just using less compute power. More of that compute is actually being used. It's not underutilized. So
That saves an organization like yours cash?
Yes, absolutely does.
And you don't have an organization that probably isn't awash with money.
Yes, right. That's right. We're a nonprofit. More so than anywhere else I've worked, we're more very sensitive about cost. But as far as things that we're doing, things that we've done, that's something that we've done. But we're always looking for efficiency and how we can improve our utilization, use less resources, and really. As a nonprofit, any money we save, it doesn't go to shareholders, it goes toward our mission, so it can be spent elsewhere. We're doing many things to help people that you may not consider, like in quite a lot of cases, the transplant hospital may be hours away from you, so our organization will fund your transportation and long-term hotel stays for family members. We're doing a lot of things that would be better spent than buying just another server because someone was just being inefficient. So
a more efficient IT budget allows you to spend money on things which there are as yet no efficiencies for, like putting someone in an ambulance for 600 miles.
Yeah, perhaps. But really, focusing on the mission is really everyone should be saving money, but it's we're reminded of our mission. On a regular basis, our organization really profiles a lot of people we've saved because we are saving thousands of people a year, and it's very humbling to be a part of it.
So Thomas, you've got millions of compute power moments every second working out what the most efficient engine is. What's the next thing for you? How do you continue to drive progress in what you do?
Well, our basic mission is always to provide highly reliable and highly efficient and a high amount of computational power. That's the baseline. So one of the next things to explore is to offload some workloads into the cloud. This is basically a business workload, not computational workload, but business workload. This might be one step. Actually, there are also some thoughts about using AI in whatever purpose. You have to get a catch for the technology.
Okay. One question from the room? One question from the room? I'm being told to wrap. Okay. Maybe the questions can be asked in person over drinks later in the Sprechspeicher. I'm sorry, I was a bit delayed. I had the all hands earlier on with our acquisition, but it's been brilliant to hear from you. Thank you so much. Excellent. Thank you so much.